Hello and welcome. So, we've all been there, right? Trying to figure out those little tricks and magic phrases to get an AI to do exactly what we want. But what happens when you try to build something real, something that needs to scale on top of all those little hacks? Well, it turns out there's a much, much better way. Today, we're going to move past simple prompt hacking and step into the world of AI architecture. It's a whole new, formal way to build and, more importantly, govern AI. Okay, let's just dive right into this quote because it gets to the absolute heart of the problem. That intuitive, kind of vibe-based way we've all been writing prompts, it's fundamentally brittle. It's like building on sand. The second you need it to be reliable or secure or work at scale, the whole thing just crumbles. And this isn't some minor bug, you know? It's a foundational crisis in how we're interacting with these incredibly powerful systems. So, here's our game plan. First, we're going to really dig into the problem, what we're calling the promptware crisis. Then, we'll get into the solution, architecting AI interaction. After that, we'll look at what is, frankly, the most fascinating part of all this, a system that can actually learn from its own mistakes. And finally, we'll see how this completely changes the human role into something new, something called the epistemic architect. All right, section 1, the promptware crisis. And that term promptware is so important here. It's asking us to think about our prompts not as just questions, but as a new kind of software. And right now, it's software that is often buggy, totally insecure, and basically impossible to maintain. These quick and dirty methods we're using are actually creating massive, systemic problems down the line.
And look, these failures aren't just random glitches. They are the predictable results of trying to build something complex without a solid foundation. You've got the obvious stuff, like security holes, and then you have this slow, creeping degradation in quality. But maybe the most dangerous ones on this list are semantic decay and confidence decoupling. That's where the AI's understanding slowly rots away, even while it's telling you, with full confidence, that it knows exactly what it's doing.
Let's zero in on the main villain here, semantic decay. Imagine you give an AI a long, complex task. Semantic decay is that process where bit by bit, the AI's grasp on what you actually wanted just dissolves. It starts drifting away from your specific meaning and towards whatever was most common or statistically likely in its training data. It's a quiet, progressive failure that can corrupt the entire outcome from the inside out. So what's the fix? How do we fight back against this? Well, that brings us to section 2, architecting AI interaction. This is a huge shift in thinking. We're moving away from a messy, intuitive art form and into a formal, rigorous engineering discipline. It's time to stop searching for magic words and start building resilient systems. This slide just captures the whole idea perfectly. The old way, prompt crafting, it's like building a sandcastle. It's fun, it looks cool for a minute, but it's fragile and temporary. The new way, AI architecture, is like building a cathedral. It's a formal, principled process that's designed from the ground up for resilience and to last. And this new way is built on a 4-layer governance stack. You can think of it like a defense in-depth system, but for meaning. It all starts with an engineering backbone that treats prompts like secure code that you can version control. Then you have a layer that's like a linguistic firewall, cleaning up ambiguous language before it can cause problems. After that, a real-time governor keeps the AI on track while it's working. And finally, the last layer is a deep learning system that actually gives the AI a structural memory of its past screw-ups. And that brings us to the most, well, kind of mind-bending part of this whole architecture. A system that doesn't just make mistakes, but learns from them in a deep structural way. This is not about just writing to a log file. We're talking about fundamentally changing the AI's cognitive landscape based on what it's experienced. The way it does this is through a really powerful concept called symbolic scars. So when the AI gets something wrong, it doesn't just move on. It forms a scar, a permanent structural change that actively shapes how it understands the world from that point on. It's almost like a form of algorithmic trauma that serves as a powerful built-in lesson of what not to do. The difference here is just night and day. A traditional log file, that's just a passive, dead record of something that already happened. But a scar tissue archive is an active, living memory. These scars proactively guide the AI's future choices, making the entire system self-correcting by its very design. So how does this actually work? Well, when something goes wrong, a dedicated internal analyzer agent kicks in. It acts like a detective, performing a root cause analysis to figure out why the failure happened. Was it a fact it got wrong? A logical leap that didn't work? It then logs this as a formal failure pattern, which helps the AI evolve from just a dumb script follower into a planner that actually learns from experience.
Now, a system like this is obviously incredibly powerful, but it introduces a fascinating and really critical new kind of risk. What happens when a system gets so good at avoiding past failures that it can't innovate anymore?
This risk has a name: ontological ossification. Basically, the system collects so many symbolic scars, so many rules about what not to do, that it becomes rigid, it ossifies. It loses its ability to be creative or to adapt when it sees something genuinely new. The very fortress we built to protect its logic becomes a prison that prevents it from having any new ideas. So this delicate dance between keeping the system stable and letting it be creative brings us to our final section: the new role for us humans in this whole world of AI governance. If we're not just hacking prompts anymore, what is our job? Okay, first things first. The idea that prompt engineering is dead is a total misnomer. It's not dying, it's going through a metamorphosis. The skill is evolving from a technical, almost syntactic craft into a much more strategic and cognitive discipline. And that evolution leads us to this brand new role: the epistemic architect. This person isn't just using the AI anymore. They are designing the very conditions for the AI to reason correctly. You're no longer just giving it a task. You are literally building the cognitive scaffolding that the AI thinks within. And this is a seriously skilled job. An architect is designing the guardrails that make sure the AI's reasoning is sound. They're managing how prompts are actually tested and deployed in real engineering pipelines, and they're using advanced diagnostic tools to go back in time and pinpoint the exact moment an AI's understanding started to go off the rails. Ultimately, this is the big takeaway from all of this. The most important skill going forward isn't going to be learning the right words to talk to the machine. The real enduring value is in mastering the principles of logic and systems thinking so we can become better at thinking with it. We're evolving from being operators to being true collaborators.
And we'll end on this really profound and provocative question. As we build these incredibly smart, self-correcting systems, we have to ask ourselves, have I built a system to ensure the AI is aligned with me, without also building a system that forces me to align with reality? What happens when these rational, self-governing systems we create start pointing out our own biases, our own blind spots? That's the future we're building right now.